Okay, this part of the video, this is part 2 of preparation for the quiz for chapter 11. And we have done example problems of grams to moles, moles to grams, and moles to particles, and particles to moles. That last calculation is sitting right there. So from there, we get to go down to now where we do 3. Okay? Now, just like with these guys that we did here, we were going from particles to moles, 2 fractions, right? Now we're going to do grams to moles to particles. That's what I just revealed there. And we're going to get rid of all the ink here. So that's all gone. And we're going to start from scratch. Notice, because there's 3 things in the path, you have 3 fractions. That's how you can tell when you have 3 fractions or 2. Isn't that cool? And when I give you those numbers include the given over 1. Okay? So this will be our given over 1. And Judith, you wanted to do this, right? Okay. Do you like to be called Judy or Judith? Okay, Judith it is. All right, Judith, I'm going to give you a certain number of grams. You pick me the atom that you want. So we're going to do 51.6 grams of what atom? Oxygen. Okay, oxygen it is. And what are we supposed to find, Judith? Atoms. Excellent. Atoms is our particle. Remember here, okay? Particles are either atoms or molecules, which is what these 2 guys are all about. And when we're dealing with grams, we're in periodic table territory, which is what this means. When we're up at these guys, we're in ovo territory because we have particles that were coming from and going to moles, or moles that were coming from and going to particles. Both of those work with the ovo number, which is right. Come on. There we go. Right down here. Okay? So, Judith, what's our first fraction? Okay, tell me what it should be. Okay, now, okay, Judith, we're at grams. How are we going to get to, or what are we going to get to next? Moles. Yeah, we just follow the path. Isn't that great? So, what has to be on the bottom? 16 grams. Where did you get that number from? Periodic table. Excellent. And what has to be on top? 1 mole. And notice that so far, and you'll find this for all of your problems, grams was given. Grams is on top. Moles was our next step. Moles has to be on top. And because moles is on top, that means that grams in what we call periodic table, P, there we go. And let's do this. And this is the ovo territory. So what do we do for our next fraction? And 6.02 is going to go top or bottom. Very good. 6.02. Yeah, 6.02 is going to go up here as particles. And this will be atoms, in this case. Atoms of oxygen. And on the bottom we have 1 mole. Okay, good. So now we have a 3 fraction problem, and we have 3 things in our pathway. And we're just about out of time. So I'll continue the video after people leave. Now this last problem, here's our path. Okay, we're going to start with particles. So let's get rid of the last calculation and let's start with our particles. So I'm going to take 3.5 times 10 to the 20th particles, which in this case is going to be atoms of chlorine. And now I'm going to do chlorine as a single, not as a double, just to keep the numbers simple. But it should be doubled when it's a gas. So over here, I'm going to have the find at the end of the path, and so I want to know how many grams of chlorine atoms that is. So we're going to start with our given over 1, 3.5 times 10 to the 20th. And this is atoms of chlorine over 1 times. Now we've got to use the AVO number because we are in AVO territory right here. Particles are AVO territory. And so the next thing I have to do is atoms on the bottom, and that is the AVO number, 6.02 times 10 to the 23rd. Atoms of chlorine, and it'll be 6.02 times 10 to the 23rd atoms no matter what the atom is. And this will be 1 mole of chlorine. And then our last one will be the molar mass of chlorine, and the molar mass is going to be on the top, which is 35.5 grams of chlorine over 1 mole of chlorine. And now when I finish crossing out, I've crossed out moles of chlorine, I've crossed out atoms of chlorine, and my only unit of measure left is the chlorine itself. And when I run my numbers, we will get the correct answer. Now we're going to go back to this guy, and I'm just going to put in the paths for you so you can then do your calculations from there. It would actually be better if you did the calculations or did all of your paths before I do mine, and that way you have a chance to see if you're correct. So if you'll stop the recording right now, I will do the path for the first one, and then you try it on your own. Okay, stop the recording. Okay, now we're back, and here's the path. Here's how you do it. You circle whatever number or whatever unit of measure has a number with it. So 4 moles of water is our number, and that's going to be our start. So the path would be moles, and after moles, you're looking to calculate the number of molecules. So that's all of them. All right, so particles. Okay, look at the second one and see if you can do this on your own. So stop the recording. Okay, I'm back. So let's circle the particle. So I know that I'm starting with particles. And then I'm going to go with moles, because moles is the thing they've been asking for. Huh? Just the simple path. You don't have to put in the atom, the stuff, whatever. Okay, let's stop the recording again now. Try to do this calcium one. Okay, I'm back. Again, we're circling the guy that has the number with it. And so we're talking about calcium grams in this case. And they're asking for moles. So my second step is moles, and I'm done because that's what we're supposed to find. Just like it was moles here, and I'm done because that's what we were supposed to find. And just the same particles is molecules, because molecules and particles are the same thing, as I showed you with, oh, let's see, where is that? There it is. Okay. Particles and molecules are the same thing, as you can see up there at the top. Particles can always be either atoms or molecules. All right, let's go on. Stop the recording, and let's do the next path. Okay, I'm back. So that's the guy that has a number with it, and we're going from moles to grams. So moles is my given, so that's the first thing in the path, and we're going to grams. Done deal. All right, let's do it now for the number 5. Turn off the recording. See if you can get the path first on your own. Okay, I'm back. Now you see we have 2.2 times 10 to the 19, and this is potassium manganate molecule, potassium permanganate molecules with that formula. And they're asking for grams. Okay, the grams are right there, and so I'm going to start with particles, and then I go to grams. Well, golly, I can't go directly to grams because there's nothing that compares those two as an equality. So particles have to go to moles first. And we do that with the Avo number. And then the next thing we can go to is grams. Okay? There is no way, if you look up here, okay, there's no way to go directly from grams to particles. That doesn't work. Moles have to be in the middle. So you have to deal with getting particles into moles and then moles into grams. Particles to moles happens with Avo, and moles to grams happens with the periodic table. Okay, one more, and we're going to be done with the video, and I'll show you the answers again. But for right now, turn off the recording and see if you can figure out how to set up your path for the number 6. Okay, I'm back, and we've got copper at 12 grams, and they're asking for atoms. So we're given it is grams. You can't go to atoms directly. Okay, you got the same problem that we were talking about up here. Okay? So instead of grams to atoms, we have to go grams to moles, the universal translator. And from moles, then we can go to particles. That's it. Have fun with these problems. Especially with these new methods, you're really going to be set to do well. And one more thing. Just want to be sure that you understand that your help sheet is a half sheet, and you can have a full front and back if you want. Those of you interested in doing well will probably want to do that. But the minimum that you need is to fill up one side. If you fill up one side, you've got full credit on your help sheet. That's it, folks. I wish you well on the test tomorrow.